In this video, we're going to talk about paths and circuits. So let's start with a path. A path is a sequence of adjacent vertices and the edges containing them. Adjacent vertices are two vertices that are connected by a common edge. So let's take a look at a few examples. In our picture below here, A and B are adjacent vertices because there is an edge that contains them. But A and D are not adjacent vertices because there's not one edge that connects them. So one path might be as follows. We have A to B, we have B to C, and C to D because A connects with B, B connects with C, and C connects with D. Now, in this same example, BCDA is not a path because D does not connect with A. Okay, so let's use the picture below to answer the questions. Is ADCBE a path? And justify your position. Well, A connects with D, but D does not connect with C. So this is not a path, since D doesn't connect with C. Okay, let's take a look at the next one. Is ACEBD a path? Well, let's take a look. We have A to C, we have C to B, we have B to E, and E to D. So this is a path. Let me write out the justification now. So this is a path since A connects with C, C connects with B, B connects with E, and E connects with D. Couple of notes here. A path doesn't need to include every edge and every vertex of a graph. A path could include the same vertices and the same edges more than once. I could do a path of A to B, B to C, C to A to D, and D to E. Okay, let's talk about circuit. So a circuit is a path that begins and ends at the same vertex. So using the picture, a circuit in this graph would be what? A to C, C to B, B to E, E to D, and D to A. So it starts and ends at the same vertex. All right, so let's determine a circuit that starts with E. Okay, so if I start with E, I could go E to D, I could go D to A, I can go A to B, and then B to E. That would be one particular circuit. Now, there are other circuits that we could write, but that's one example. Okay, so now let's do a circuit that starts with C. So let's do C to A, then A to D, then D to E, E to B, and then B to C. So I can write it C, A, D, E, B, C. Again, there are other circuits that start with C that we could have done. This is just one particular example. So keep in mind that every circuit is a path, but not every path is going to be a circuit. Okay, now let's talk about a connected graph. This is a graph where any two vertices have a path that connects them. So the first three examples below are connected graphs. Any two vertices has a path to be able to connect. For the one on the left, A can be connected to C, A can be connected to D, A can be connected to E through AD and DE, so on and so forth. If a graph is not connected, then it's what is called a disconnected graph. The graph on the left at the bottom, there's no way I can connect A to C, no way to connect from A to B, and there's no way for me to connect from A to D. In the middle, there's no way for me to connect A to E, or A to G, or A to F, or A to H. For the third example, edge AD and edge BC cross. The graph is not connected since there is no vertex where the edges cross. Okay, let's take a look at this example. So I want to be able to determine if this is connected or disconnected. Well, take a look at A. Is there any way for me to connect A to C, or A to F, or A to G? So the answer to that is no, so it's definitely disconnected, since there is no way to connect A to C. Again, keep in mind, no way to connect A to F or A to G, but I only need to show one particular example here to show that it's disconnected. So the last thing we want to talk about is a bridge, and this is an edge that, if removed from a connected graph, would create a disconnected graph. So the three pictures below show examples of bridges. For instance, for the left, if that bridge is removed, there's no way that A would be able to reach B. There would be no way A would be able to reach C, or A would be able to reach D. If I got rid of the bridge in the middle picture, there's no way that A can connect to E, or A connect with F, or A connected with G, or A connected with H. And there would be other vertices that wouldn't be connected also. Okay, so let's use the picture below to identify any bridges. So if I removed anything, would there be vertices I wouldn't be able to reach? Well, the answer is yes, because if I remove segment BD, then there would be no way for A to be able to reach D, there would be no way for H to reach D, so on and so forth. So segment BD is a bridge in this case.